Well, hello and welcome to this week's episode of Random Access. You're going to love this one. We have two guests from NASA Ames this week. And gentlemen, you're systems engineers. We have Daryl Levasseur and we have Rob Hansen from NASA. Welcome.
Thank you. Thank you for having us.
And I noticed we have something else. Is this R2-D2 or what do we have here?
Well, that's pretty darn close. This is actually spheres. It stands for Synchronize, Position, Hold, Engage, Reorient Experimental Satellites. There are currently 3 on the International Space Station and several more down here on Earth. So we're here to talk about that, I guess.
Okay, spheres, but this is sphere, right?
That's true. This is a single sphere. Yes.
Okay. So I'm curious, it's small. What in the world does this do?
So what we have is what you're looking at is an actual sphere. We have 3 on station and we have 3 on the ground that we use to practice with. So inside the International Space Station, there are 3 of these, and we call them by their colors. So we have red, blue, and orange. This one is obviously black, so he's different from the ones on station simply in color. But other than that, they're identical. So what this little tiny robot does is he sits up in station. The astronaut gets him, he puts him right in the middle of the International Space Station inside the GEM module, which is the Japanese module, and it sits there and it floats because there's no gravity. And then what they do is we run software, and all of a sudden it comes to life. So the way these work is we actually have CO2 bottles that they run off of. Actually have one. They're very, very similar to what you would find in a paintball device.
Yeah.
It's just CO2 inside here, liquid. We screw it inside the spheres, and that gives it gas to thrust itself around. It opens up these little ports, which I think Robert could point out and show to you. And what it allows it to do is it allows it to move. And so you wonder, what's so special about a little ball in space that can move around? There's actually a lot of science we gain out of it, which is really important. Because every time it makes a movement, it's a very controlled little amount of force. And of course, you know, physics, anytime you have force, you're going to have an action. And so the sphere will move around the room. So we've actually had spheres up there for 10 years now, which is a huge amount of time to have science inside the International Space Station. And so we've had many different operators, many different guest scientists, and we tried different experiments. But what it was initially designed for is to test those movements out. We call it control theory. We try different little bits of software and a little bit of science, and we want to know how it behaves. So if we're going to send a rocket off to space and we thrust it a little and we think we do the opposite and it should stop, well, sometimes it doesn't.
So I've seen 2001: A Space Odyssey with HAL, and I've seen Gravity, where these things were a disaster. Have you ever had any accidents on the space station with this device that you can talk about?
That we can talk about.
Okay.
Fortunately, no. Nothing too catastrophic has happened. I think spheres sometimes likes to get a little lost where it's at, and worst case, it just kind of drifts off in a direction they don't want it to. Fortunately, they can very easily, or I say they, and I'm referring to the astronauts, they can very easily just hit a button on the keyboard and stop it and start that test over again, which happens once in a while, and that's part of the science, is that learning. Every once in a while, they put a line of code in there, and you try to test for it, and it doesn't do what you wanted it to, and so they have to try it all over again, and that's the part of that learning process, and that's what makes spheres so important.
So for somebody who has an interest in doing something like this, what inspired you to become involved with NASA? How did you get a job? How was your schooling relevant to what you're doing now? And is this your dream job?
Ooh, dream job. That's a fun question. I would say my interest in NASA started, I took a field trip, I think in the 7th grade, and I remember we actually went to NASA Ames, interestingly enough, and they had a couple of the students get in that gimbal where they spin around in all the different directions, and they said, if you're an astronaut, someday you get to experience this. And I just remember thinking to myself, that's not very exciting. But then they took a blowtorch to some shuttle tile, and then they got it real hot, and then they allowed someone to touch it, and it was nice and cool. And I thought that was fascinating.
That's the good stuff, yeah.
That's what sparked my interest.
How about you, Daryl?
I think it's funny you bring that up because, so we actually have a video of the spheres doing their behaviors in space, and what really caught my eyes when I was young, I saw some early video footage of an astronaut floating in space, and when you really grasp and get to see microgravity or zero gravity, and to see something floating and moving around, it really, it's surreal because it's not something you can experience here on the ground.
Yeah.
So you always wonder, what's it like to float around and be able to fly across the sky?
Pretty amazing.
Yeah.
You got me, so maybe we have some tape we can take a look at. Oh yeah, there we go.
Yeah, so what you're seeing here is the spheres doing their behavior. It's sped up because in station we're in no hurry, so we make sure that all the movements we do take their time. But we can see here is an experiment where they're learning to navigate around each other for like inspection. So if one vehicle was damaged and we had another that had a camera, we could look and see what the problem is. So here's actually our facility on the ground. We have another video that shows the opposite of that. So we don't just have the spheres in station, we actually have them here on the ground because we have to practice before we do things on station.
Absolutely.
So we have this beautiful hunk of rock inside of our facility called the Granite Lab because it is a 4-foot thick piece of granite. And what we have here is essentially is very similar to an air hockey table. The spheres gets to ride on this cool little platform called the air carriage, and it has its own CO2 and it pushes it through the base, and it's kind of like a hovercraft. And so that allows us to test inside of our facilities.
Nice. I'm curious because you're NASA Ames. I know JPL does similar stuff. So what's the difference between NASA Ames, what you're doing, and Jet Propulsion Labs in Pasadena? Do you cooperate?
Yes, actually we do, but JPL is world renowned. Everyone knows it's because they do the big ticket missions. They do really long-term, very expensive, very impressive missions. NASA Ames here in the Bay Area is we're a smaller center, we're a research facility. And so one of the best things that we've done over the past several years is we've really transitioned to smaller satellites. We do a lot of things called CubeSats. And so what we've gotten really skilled at is the smaller satellites. And the way the economy is going and the way technology is going, getting smaller and cheaper and more efficient, is everyone is looking at how we can make satellites cheaper, smaller, and faster. And so Ames has become very proficient at that. And that's also very closely tied to spheres, because a lot of that research that we gain from the knowledge on spheres inside of station goes to other small satellites as well.
Very cool. Tell me about some of the things that this has accomplished in the International Space Station, and then also is there applicability to the commercial world, perhaps? Maybe two questions.
Absolutely, yeah. So I'll take a tackle at the first one. So more recently, one of the experiments that we conducted was a program called SLOSH, and it was a partnership with the Florida Institute of Technology, and what they were looking at was fluid slosh movement in microgravity. And the reason that that's so important is lately there's been a lot of talk about doing these missions and long duration trips to Mars, and when you're traveling there, you're going to need to be transporting water and fuel and other materials, and so it's important to know what happens when you're flying around with a lot of extra liquid in zero gravity. And so we can test on a much smaller scale on the International Space Station, try to match it to simulations and models to get closer and closer and better results. I think we actually have a photo of what the SLOSH experiment looks like. It should be a green bottle.
Okay, yeah, there we see it.
Yes. So that green bottle is about 40% full of, it's actually just water with a little bit of green food coloring in there. And the astronauts had such a fun time moving and shaking that thing around because it looked like some kind of crazy jello ooze inside the space station. So it was a very neat experiment.
So tell me a little bit about the inspiration for this. So I imagine you've seen a lot of robots. I've seen a lot of robots coming from Lost in Space to Star Wars to all that. Was there any inspiration that was gained from any of those movies? Or
I'm so glad that you mentioned Star Wars, because the actual original inspiration for spheres was Star Wars. Professor at MIT for his senior design showed a clip of A New Hope where Luke is in the Millennium Falcon and he's swinging the lightsaber around with the shield over his face, and there's that little droid that's moving around with him, and the professor showed that clip to his students and said, I want you to make me one of those, something that can float around on its own inside the International Space Station.
And sure enough, here it is.
10 years later, we still have it floating around.
That's really nice. It's an amazing little piece of engineering, that's for sure. You must be very proud of that. Is this your dream job, would you say?
I'm completely happy with my job. It's such a diverse field that we do. We do so many different things at work relative to spheres and small satellites alone. It's very rewarding.
What's your typical day like, Rob?
Oh, it's funny you ask that, because that's always the typical question that friends of mine ask me. What's a typical day at NASA like? And I don't have a straight answer, because every day is different. There's some days where we're sitting and computing and trying out new versions of code and experimenting in the Granite Lab, what you saw the video of, and there's other days where we're down building flight hardware that'll soon go up in space. And so it's that diversity that makes us wanting to keep coming back to work every morning. It makes it all worth it.
Absolutely. Now, is there Spheres 2.0 on the way? Can you
Yes and
reveal
no.
anything about that? Or
Yes and no.
Okay.
So spheres eventually is going to have an end of life. The science will run out, and the actual hardware will become obsolete. So we have another program at NASA Ames called AstroBee, and it's not quite a replacement, but there's a lot of similarity. So it's going to be inside the International Space Station, and its intended purpose is to do tasks that the astronauts shouldn't have to do, kind of trivial menial tasks that are important, but a robot could do better. Say sampling the air or doing inventory control with an RFID wand, kind of like they do at the mall with inventory.
Right.
So it's going to be able to go around different parts of the ISS, whereas right now Spheres has to stay in one particular module because of the way it's designed. Obviously a robot has senses just like we are, or we have, and if we know we're in a room, well, the only reason we know that's because we can see the walls. We use our eyes or we use touch. Spheres uses a very interesting method, which is kind of like echolocation, like a bat would use. It's very similar to the thunder and lightning scenario that you remember when you were a kid. You'd see the lightning, and you would count on your fingers how many seconds it was. Well, that's how Spheres works. It uses light and sound that the astronauts can't see or hear, and lets it know where it's at. But because of that, it basically is only useful in one particular area of the ISS. So AstroBee is going to have the capacity to go to different parts and have different capacity and different tasks, and it's going to be able to perch onto walls and hold cameras and help out. So we couldn't have gotten to that technology level without using the knowledge we've gained from Spheres, which is the whole premise of everything we do at NASA, and the science is we take a little bit of knowledge and we put it towards the next step till we can get to our final goals.
Okay. Well, that's about all the time we have, unfortunately. This has been fascinating. I could spend a lot of time talking to you about this. It's a great job that you have, and you guys are doing great work, so thank you so much. And thank you for being here. This is Random Access, and my name is Alan Lundberg, your host, and we hope to see you next time.